In this video 1.5, we will be adding and subtracting real numbers. So by the end of the video and work time in class, you should be able to say, I can add and subtract real numbers. Absolute value is the distance a number is from 0 on a number line. So on my number line, I'm going to locate 0. I'm going to put 0 in the center of my number line, and I'm going to make some tick marks in both positive and negative directions. And if I take my number line and locate, let's say 4, and let's say -4. I'm looking for absolute value. You would see two vertical lines like this. If you saw something like that, that would be asking for the absolute value of 4. You want to know how far is 4 from 0 on the number line. So we see 0 here, and it is 4 units away from 0. So the absolute value of 4 is 4. Now if I want to know the absolute value of -4, I have 0, -4. This distance is also 4 units. So the absolute value of -4 is also 4. It's how far it is from 0 on a number line. Now when we add real numbers, when the signs are the same, you find the sum and you keep the sign. So if we had like 3 plus 4, the signs are the same, they're both positive, so we find the sum and the total is 7, and then we keep the sign. Well, the sign was positive in the problem, so our answer is positive in the solution. If I have -3 plus a -4, the signs are the same, they're both negative. You find the sum and you keep the sign. So if both of them were negative, we found that total and kept that negative sign with it. Now when the signs are different, here, we're going to find the difference instead of the sum, and we're going to keep the sign of the greatest absolute value. So I'm going to write down a couple examples. So if I had -3 plus 4, the signs are different. One is negative, one is positive. So I find the difference of 4 and 3, which is 1. Keep the sign of the greater absolute value. Well, 4 has a greater absolute value than -3 does, because the absolute value of 4 is 4 and the absolute value of -3 is 3. And since 4 is positive, my answer is positive, 1. Now if I had 3 plus -4, the signs are different, find the difference, but on this one my solution would be -1 because -4 has a bigger absolute value than 3. And since -4 is a negative integer, our answer is going to be negative. Opposites are two numbers that are the same distance from 0. So very similar to when I had 4 and -4. So if I have 0 here, if I'm looking at 3 on my number line, the opposite of 3 would be -3. They're the same distance from 0. They're both 3 units from 0, so they are opposites of each other. Now whenever you have opposites and you add them, this is called additive inverses. A number and its opposite. So for example, 3 and -3 are opposites. And when we add them, we have the inverse property of addition, which says whenever we add opposites, we get 0. So any number plus the opposite of that number is 0 no matter what. So if I did 3 plus -3, I get 0. If I had 14 plus -14, I get 0. If I had -14 plus 14, I get 0. 10 plus negative 10, 0. Negative 23 plus 23, 0. That's the inverse property of addition. So we are going to look at subtracting real numbers since we did addition. To subtract a real number, you add its opposite. All subtraction problems can be turned into an addition problem by doing exactly what it says up here. Some real number minus another real number is the same as that real number plus the opposite of that second real number. So let's use an example. 3 minus 5. Well, 3 minus 5 would be the same as if I took that and I wrote 3 plus the opposite of 5. And then we could get our solution, which would give us a negative 2. Now, if we had something like 3 minus negative 5, we can turn that into addition. 3 plus 5, which gives me a solution of 8. Now, what I like to do is whenever I see, like right here, a minus a negative, so if I was going to rewrite this problem, if I had 3 minus negative 5, whenever I see a minus negative, I connect them and make addition, because taking away a negative is the same as adding. And from here I'm following my rules. The signs are the same. I find the sum, I keep the sign. So we have some examples here. So 4 plus 7, signs are the same. Find the sum, keep the sign. Number 2, negative 4 plus negative 7, signs are different. Find the difference, keep the sign of the greater, absolute value. Number 3, signs are different. Find the difference, keep the sign of the greater, absolute value. Number 4, signs are different. Find the difference, keep the sign of the greater, absolute value. And number 5, negative 15 plus negative 4, signs are the same. Find the sum, keep the sign. Number 6, negative 3.6 plus 10.8, the signs are different. Find the difference, keep the sign of the greater, absolute value. 3 problems I'm going to bring up here for subtraction. I'm going to change them all into addition. So negative 6 minus negative 12 turns into negative 6 plus 12, which gives me 6. 2.1 minus 9.6 is 2.1 plus negative 9.6. Find the difference, and then keep the sign of the greater. And the last one, 5 minus 5, I don't need to change into 5 plus the opposite of 5 because I already know it's 0, but we can see the additive inverse property taking place there. A reef explorer dives 20 feet to photograph brain coral and then rises 7 feet to travel over a ridge before diving 31 feet to survey the base of the reef. Then the diver rises 18 feet to see an underwater cavern. What is the location of the cavern in relation to sea level? So sea level is an example of where we deal with a lot of positive and negative real numbers. And so we, describe this diver's experience using integers, if the diver dives, it's negative 20 to photograph, and then rises plus 7, and then dives 31, and then rises 18. This expression would represent the diver's change in location. And when we simplify from left to right, we end up at negative 26 feet, following the rules from the lesson. Can you say I can add and subtract real numbers? Write a summary and reflection and be prepared for work time in class.